The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and welcome to another D-Link webinar. They say you shouldn't do sequels, but we're bucking the trend and we're going back. Due to popular opinion, a lot of people talked about the business continuity webinar that Craig and myself did a few months back, and a lot of the questions were, can we have a little bit more detail on the network redundancy, go into a little bit more on the spanning tree protocols and just talk a little bit more in depth on that kind of stuff. So I'm very happy because it's going to be another webinar when Craig does most of the talking. Hi, Craig. How are you doing?
Hello, everybody. Hello. Thanks, Alan.
Oh, I love it when these webinars get a little bit more technical. Business continuity. So the whole point about network redundancy is to try and avoid downtime, try and avoid unplanned downtime, which can be a major drain on business resources. We've got some stats on the screen which talk about the American model, and these numbers are, there's more research that exists in America, as you can imagine on this. We do have some stats on the UK market, and I'm going to ask Craig the question. Craig, you haven't seen this, but how many business hours do you think are lost to internet downtime in 2018?
Are we talking across the UK or is it localized?
Across the UK and in millions.
In millions? Oh, I don't know. It must be, I'm going to throw it out there, Alan, 40 million?
It's 60 million hours.
60. Oh, wow. See, that's a lot.
Even a network professional like Craig has gone in 50% under. So that's a lot. That's a lot of hours. It really is, isn't it?
It is.
42% of businesses, some 2.4 million nationwide, suffered at least one significant internet connection failure in 2018. So these numbers really are truly staggering. And I think what we're going to talk about today is how to weigh up the cost of installing redundancy versus what you would actually lose in terms of productivity from your business. You know, with predictions of between $926 to $17,224 per minute, obviously dependent on industry. It's got to be worth looking at a redundancy solution. Craig, did you want to talk about these bits a little bit more here?
Yeah, so this is really what crisis management and emergency redundancy is what we're really talking about, and how it can actually affect your business. I don't remember if you remember a few years ago when there tend to be a lot of bomb threats and things like that was going around. Places were shutting down, police were on high alert. And you'd be surprised at how this can affect businesses in terms of power outages and things like that. Obviously natural disasters, but what we're really talking about, especially in today's day and age, is when the internet goes down, more importantly, when your devices locally go down. That's really what we're going to be discussing today, because obviously you can have the most robust device out there that does everything. It makes your coffee and it keeps your business up and running. But when that fails, what happens afterwards? Obviously, we're looking at these figures, and that's a very real figure. You just said, Alan, that's 60 million hours of downtime that is lost. Now, with some correct budgeting and correct management, but more importantly, some correct planning, and that planning extends to when you're designing a network, we can avoid a lot of these problems at our local side. Now, obviously, if an internet connection goes down, that might be a little bit different. However, even that internet side, you can still think about a little bit of redundancy. There's a lot of technologies that are open to us now, and we're talking about ADSL, VDSL, which is some older technologies, but still quite commonly used. But 4G and 5G around the corner, is really something that we can start thinking about implementing into our bigger business networks, because there's so much bandwidth that's available to these newer technologies now, especially with 5G coming out now and rolling out across the country. The amount of extra bandwidth we get, the lower times in terms of latency that are provided with those, and the actual technologies for things like Wi-Fi 6 and other devices, it really is something that can be rolled out quite easily to make sure that our businesses is constantly up and running. And we're going to go through some designs and some technologies that's built into our fundamental core switches. And when I say our fundamental core switches, what I mean is pretty much every device that we have for our switching series, which is that smart range, the managed range, even the core. So right on our edge, right up to the core, has some of these features available to it. Maybe not all of them that we'll go through, but most of them. And just a little bit of planning. And what I really want to take away today is some concepts that you can go away and think about, especially if you're doing that network refresh, but more importantly, look into what you've already got installed, because a lot of these technologies, what we do here at D-Link, is based upon the standards that the IEEE provide. So it doesn't have to be that you have these D-Link devices. You can probably implement a lot of these technologies on what you've already got. And certainly if you are thinking about D-Link, it's worth looking at seeing what of these technologies you can implement in your currently existing or maybe in a refresh in the future, so that you can start planning that redundant part of your network.
I think going back to what you touched on about 4G and that, Craig, a lot of people just don't realise just how fast 4G is, and that's just the long and short of it, isn't it? I mean, you've talked about your personal 4G connection is faster than your home broadband connection.
Massively faster, massively faster. People... I mean, I have a VDSL product, and it's actually a very good consumer product. I've got a great line, but it only goes up to 50 meg. Now, what I can get with 4G, just roaming around, I mean, we're going excess of 70 meg lines, and that's when I've got a bad signal. So it's really good. And that's a 4G connection LTE. So imagine 5G around the, like I said, it's around the corner on newer devices now that are coming out, and it's certainly on 5G routers where you can insert the SIM card. It's a real thing. It's got limited amount. You know, the amount of bandwidth that you can get on this is worth having as that backup.
It's going to be crazy. Oh gosh. So we're going to look at some switching design concepts now, and just going to give Craig's voice a little break while he introduced this slide. So we're going to look at some real life networks examples, and then get into the different types of redundancy, the different types of setups that you can put into place. So here's the first. It's just a typical office scenario here, right?
Yeah, I think anyone who's been following our webinars will have seen this before. This is actually taken from I believe it's our network building blocks webinar, Alan. So what I wanted to do for anyone that has been following us is I want to expand on this a little and see, because I've talked about the redundancy and what this design means, but let's have a little bit more of a focus on where you implement the technologies and what that can actually mean. We've thrown in a couple of graphical user interfaces slides as well, so you can actually see how it's implemented as well.
Sure.
So we're going to start by looking at our stack. Now, just to be clear, let's go right from the beginning. We've got our router at the top that provides our internet. We have our core switches, and then the core goes to our distribution switches, and our distribution switches, or aggregation switches, if you like to call them that, provide our edge network, and our edge network then has all of our devices plugged into them. So what we want to have a look at first is stacking, and what stacking actually does. So I think on the next slide, Alan, what we'll see is what you do without stacking. Now, this is obviously traditional networking. So you have a switch, you give that switch an IP address. Maybe at some point you want to expand your network, so you have another switch, or maybe that's in a different area, and you start plugging them in. Every switch has a different configuration, a different IP address, and before you know it, you start daisy chaining, you start thinking about how they're going to work, where they're going to go, and all of a sudden you're in this big mess where you just keep building and building and building. And if you ever want to make a change, certainly if you want to start using VLANs and things like that, then you have to think about, well, how am I going to implement it? What am I going to implement it on? Got to keep this big list of what's going on. And if one of these switches goes down, it's a nightmare, right?
Yeah.
So it's going to take out a lot of your network. So what stacking does is we're able to take one switch and build upon that by adding our switches in a logical way so that they actually have the same IP address. Think of them as one switch with many, many ports, and they're all linked together using our particular cables. Now, what these are linked with are called DAC cables, direct attached cables. They're 10 gig cables, so they provide, each one of those wires there provides a 10 gig connection. You link one from the other, and then you loop that back around, and that's where your redundancy comes in. So for example, if you look at that third switch down, now imagine that third switch down stopped working now. Is it going to affect the rest of the stack? No, it's not, because the traffic can still get to each other around, so it doesn't actually have to matter. Now, that's one stack. What happens now if we have multiple stacks? Well, all those multiple stacks have got the same thing. They've got the redundancy, but now we have to uplink our devices. So this might be a core, it might be an edge, could be anywhere, right? But what we want to do is we want to link the traffic of these. So we obviously have to have another connection that goes from one to the other. Great. So now we've got our uplink, and we can say that's a 10 megabit connection, right? Because we've got a 10 gig fiber cable going between them with some transceivers in there. Now, obviously, what happens if one of those links goes down? We've lost connectivity between each stacks. So we introduce another switch, another cable into our stack. So now we've got our redundancy. If one of those links goes down, we know we've got a backup 10 gig link to keep going. However, with a little bit of planning, a little bit of forethought, what we can actually do is, rather than say a 10 gig connection with a backup 10 gig connection, what we can actually use is both of those connections at the same time to give us a 20 gig link. Because if the connection is there, why not use it at the same time and increase your throughput between these stacks, making your network much faster and also including that bit of redundancy.
So you mentioned about the core switches there, Craig. The salesman in me comes out and just says that, just to remind everybody that 10 gig core switches at the moment, 20% off. So give your sales guy a call if you've got anything interested in there. And as well as this, on the stacking side of things, the new 1520 switches that we introduced in the Wi-Fi 6 handout last week. Very, very good for this stacking with up to 8 1520s in a stack for that 80 gig full speed connection there. So definitely worth having a chat if you're interested in upgrading the core of your networks at the moment, because Dean's got some new products and some good offers on at the moment. Sorry, plug over back to normal service.
Damn advertisements, I can't get away from them. Right, so another diagram to show us what that actually means and how we can do it. So we've got financial department, we've got sales department, and that's going to have a stack per switch. Now, if you're at school, this might also be a different department. It might be an art block, it might be a sixth form block. You can look at it that way. Or if you're a big business, various things that you can use it for. But generally, you'll need a couple of switches in different areas that are fiber cabled together. So those are going back to our core. They're providing all of our edge network back to our core. They're all stacked. They've got that redundancy. They've got those extra links. And then they can go back to our top of the rack for our data center areas. But this is like an example of a big management. So you can do it at the big management side. You can do it at the small management side. It doesn't have to be a massive implementation to just think about a little bit of redundancy. Even if you're just looking at maybe 2 or 3 switches, 2 or 3 switches in a stack is going to give you some redundancy between each other. It's also going to increase the throughput for when you're actually connecting devices, because generally you get a dedicated stacking cable, and that's always going to be a really good quality fiber connection that you've got there anyway. So even if you're a smaller business, think about stacking devices and those stack switches, because it can be really, really handy for it. And I think our 1510s, like you say, Alan, are currently currently in that pipeline for the, is it 1520s that are there?
1520s, yeah.
1520s. So the 1520s, just to give you a little overview, they're our new switch. And what they actually provide is, rather than having to stack through these dedicated stack cables, it's actually a new way of doing it. What we can also do, they come with 2 ports of 10 gig Ethernet, and you can stack with 10 gig Ethernet. So what that means is you can cut down on some of the costs required for stacking with that new switch coming out. So that's something that we're really looking forward to see. Okay, and the next slide, Alan.
Yep. Just
So
taking a little bit
our,
of time on the delay. Sorry, it's a little bit slow today.
no problem, no problem. So I mentioned 10 gig stacking. What that is SFP plus. So if you see the term SFP, it generally means 1 gig. If you see SFP plus, generally means it's a 10 gig connection that you've got there. Now, if you notice on the bottom right-hand corner of that, you've actually got an ideal way of it being implemented. So you've got a building block there. You've got 3 devices that are all talking to each other. You've got another 3 devices in a different block that are all connecting your devices. And between those blocks, we've got some links. Now, what you'll notice there is that's actually in a kind of ring, and we're going to go into rings in a moment, but you can see already that you've got stacked devices, and you can stack at distance as well. It doesn't have to be in the same block. Stacking, when we say physical stacking, we don't mean locally. What we mean is physically stacking. So they share one IP address, one management, one MAC address, so that when you connect into the device, it's all managed from that single web user interface or CLI commands. And it doesn't matter how many ports, so you can have a 28 port model or a 52 port model, as long as it's on the same series. So 1510s stacked with 1510s, 1520s stacked with 1520s, 3130s stacked with 3130s.
And the same true for PoE models. I'm assuming, Craig, you can stack PoE and non.
Yeah, absolutely. So in the 1510s, for example, we have 28p, we have 52p, and we also have max power versions as well. If you've got a lot of PoE power that you need across that for,
you don't need a full stack of PoE switches, do you? You probably need one to run the cameras or the access points, and then you can
absolutely.
save money.
So what we, if you imagine a stack of say 6 switches. Maybe one of those devices can be PoE. If you really want to be factoring in, maybe 2 of those devices can be PoE and the rest can just be data ports. Yeah. That way, if one switch does go down, you can potentially just swap over some cables manually to power on your PoE. But generally, it's you throw in 1 or 2 PoE switches per stack. That way, you can plug all your access points and things in.
It's a bit of CLI.
So this, yeah, a bit of CLI. So what I've done is I've gone onto Google and I've typed in the IP address of the switch, gone into the management after putting my login names, and then I go to our management panel and go to physical stacking. And what this actually means is I've enabled physical stacking on the device. And what you'll see here is when it's in that mode, it tells us the information of all the switches that are in that stack. So what I've done is I've cabled 2 of these devices together. There is actually 3 there, but the 3rd one is actually down. So you can see which one's up and which one's down. It's very important to get the firmwares the same when you start to stack as well. So put them on the same firmware before you begin to stack. Quite important that. And then you can assign priorities. Now, how this works is out of the box, a switch will come as a priority of 32 or lower, right? So 1 being the top, and then 32 being the bottom. So every switch will be at 32. That way, when you add a switch to a stack, it's going to grab the configuration from what is called the head, right? So what you'll generally have is 2. You'll have a top head and a second head. Now, if the first head goes down, obviously the second one kicks in. If the second one kicks in, then it just goes to the rest of the switches in your priority order. But on the front of the interface, there's actually, on the switch itself, there's actually a stacking ID number, and you can see very clearly the unit numbers for each unit and the priority that they're assigned. So you can always know which one's the head and which one's the second head, ready for taking over and that sort of thing. It just makes it easier for cabling up, and just so you know how it's going to go down the chain of priority.
Okay. Next network.
Yeah, so that's same back to our same network. So we've looked at the stacking side now. So if you imagine those 4 units we've got there, we've got 4 stacks, which is 2, 4, 6, 8 switches there. So 8 switches. But really, we've only got 4 IP addresses that we need to actually worry about and think about for our core and our distribution area there. So let's have a look at the next part now, how we can start implementing some additional redundancy when we start uplinking. So here we're going to have a look at our distribution. Now, if you're in a smaller company, that might not be a distribution, that might be your core actually. And what you might want to do is put some edge devices straight into the core. Now, notice what I've done with those 3 switches that are linking. There's actually cables running between each other that we might want to utilize. Now, if you was to just take out a switch and plug it in like that, you'd actually create what is called a broadcast storm. Now, a broadcast storm is something that can actually take down a network very easily because it's a way of trying to send information, and it looks at the MAC address, and the way switches work is that they broadcast out their information to try and find each other. Now, when you're doing that, it's just broadcasting all the time. It goes to the next switch, that one starts broadcasting, and it goes round and round and round until there's too many packets in the system and the whole network crashes and the switches can't cope. So it's very important that when you make these kind of designs and you make these kind of topologies, that you're using switches that understand features that can stop broadcast storms and implement what we want to implement. Okay, so here I've got a ring topology. So let's have a look at what ring topology actually does and what that means for some of our design. So standard ring, here we've got 6 switches on the left, and those 6 switches are just in a very standard ring, throwing information around. Now you imagine if one of those switches goes down, we have redundancy. That means we can go the other way to get to the switch. So we can think and factor in how we got that redundancy. So what we need to do is implement some technology into that to stop it having that broadcast storm. But we still want the ring. The ring is very handy for us. Now on the right hand side is star topology. This might be something that is more familiar because it's got that core concept. Now the benefit of that star topology means that if you think about hop-wise, it's very close. So it's always going 1 hop to get to that core switch. And if it wants to go to something on the edge, it's only 2 hops away, right? So it's 2 hops. It's very optimal in terms of sending traffic. But think about it, if that core switch goes down, that's a problem because the whole network goes down. You've lost everything.
That's the exact question I was going to ask then, Greg. What happens if the core switch goes down in this case? Because there's no connection between the switches on the edge at all, is there? So
absolutely, yeah. There's nothing. There's absolutely nothing, and that's kind of unfortunately we see this design a lot. It's an older design, but what we want to do is we want to merge these 2 together. So if you look on the left, if we have one of the switches goes down, yes, we can still get there. But think about how many switches that has to go through if those 2 switches are furthest points away from each other. We have to send all that traffic through the switch, which means every switch has to be able to handle its own traffic plus the traffic of the other switches as well. So yes, it's got redundancy. The other one doesn't. But the other one has this optimal pathing that we can send information on, but doesn't have the redundancy.
I wonder where you're going with this, Craig.
Where am I going? Where am I going, Dan?
I think I know because I can already see the next slide.
Yeah, there we go. So meshing and partial meshing. These are topologies that we want to implement, really. Now, notice the one on the left. This is full redundancy, right? If any one of those switches goes down, it can always get to the other switch. It's direct. It's 1 hop away. Great. However, in a real world scenario, cabling costs money, right? So it costs money. We want to reduce the amount of money that we spend, right? That's a no-brainer. We can't throw in everything that we want because otherwise we'd all be riding Ferraris, right? So what we want to do is we want to keep our redundancy. We might have to lower it perhaps, but we can still have something that's a really good design. So keep our redundancy, keep that optimal pathing, but also keep the costs down. So these are things that we have to factor in that when we do our network designs, because obviously these are three things that we must have in order to keep our business running. You can't throw money all over the place and buy everything all in one go. That works absolutely amazing like a data center. Everybody has their limits and their budget, and it's about meeting your budget and trying to factor in pathing and optimal sending, and you're keeping your network optimal, plus that redundancy period. Okay. So, spanning tree protocol. What is spanning tree protocol? Spanning tree means that we are introducing our redundant links, right? So what you want to do on a managed network is create redundancy where we can have those pathing. So here is an example where I'm sending traffic from A to C as an example, right? So I can see that I've got A to B, that's fine, B to C, that's fine. My redundant link is A to C. Now, you might think to yourself, well, that doesn't seem really beneficial because I've got a link that goes from A to C and I want to send traffic across that way. Wouldn't it be better? Sometimes yes, sometimes no. Sometimes it's just a case of having that link available to you, coming up and coming down when it's needed. Okay, so the next step would be the second step of spanning tree protocol, where we can choose how that information flows to get from A to C and C to B, right? That's what spanning tree allows you to do. It allows you to create these route bridges that can define the shortest path how to get to somewhere. However, we have our backup link. Now, what spanning tree protocol would do is it will recognize the traffic that is sending across those ports, and it won't create that broadcast storm. So it's very simple to actually implement. All you have to do is go onto the switch itself and implement the spanning tree protocol. Is literally just a global setting, and as long as it's on every one of your switches, they'll understand that they can pass on, and generally what they'll do is they'll choose the fastest path anyway to get to those devices, but it won't do it in such a way that breaks your network. So sometimes just implementing spanning tree protocol is enough to get that link going.
To make use of this kind of spanning tree protocol, Craig, do you need a smart switch? Is that kind of the entry level for this kind of protocol, or is it on an unmanaged switch, for instance?
Yeah, that's a really good question, Alan. It's not going to be on an unmanaged switch, right? I can tell you that now. And reason being is it has to have some logic there in order to understand it.
Right.
You have to implement it as well. So it's an on-off feature. And generally, you're not going to find on anything other than something that's either smart or managed, okay? The problem comes from implementing unmanaged switches into a design like this. It is possible, however, it must be done on the edge, and it mustn't be part of that routing block either. So generally what we can do is, let's say we have a smaller unmanaged switch plugged into A, that's fine. A, we can do our logic, and the switch itself, when it hits A, will then join the rest of the network. However, if you try to have A as your unmanaged switch, that's not going to work. It's not going to be able to do it properly.
Yeah. Well, okay.
Now, I mentioned that ring topology, and we can implement some things like spanning tree protocol. If we want to go a step further, what we can actually do is implement something called ERPS. What that means is we can have a fast mechanism for failure. So it detects and talks to each other around that ring, and we can actually get under 50 milliseconds throughput. That's barely a ping loss of recovery time when something actually goes wrong and fails. Very important to understand that it's a different technology to spanning tree protocol, whereas spanning tree protocol will understand that it can take a link out, take a link in. The idea behind this is that you actually tell the switches which port is in, which port is out to talk in that ring, so that if any one of those fails, it can go the other way very quickly, okay? Now, just to be clear, ERPS is not necessarily a D-Link topology. It's actually something that's very standardized. The nice thing is that it can work with other switches as well. It doesn't have to be D-Link as long as it supports that ERPS, which is G.8032, okay? So how I would implement it on our 1510s is I would go to our layer 2 features, because it is a layer 2 feature, go to our ERPS, and then that's when I choose which port is in and which port is out. So here what I've done is I've just selected my Ethernet. So that's unit 1 port 1 and unit 1 port 2. Imagine if they were in stacked, you have different units, of course, and then you can choose what's in and what's out for those ports. Okay.
Okay. And just to mention, just to give Craig a quick break from all of his great work here. Any questions? Type them into the sidebar. We'll pick up the questions at the end of the session as usual. You'll also see in the handout section there is a copy of this presentation which you can take away in PDF format. And if you have any questions that come up after the webinar, you can always drop us an email. We'll show our contact details at the end of the webinar there. So just to buy Craig a quick break then before we move on to going back to our network diagram.
Yeah, so we have that distribution area, and we've got that ring redundancy that we factored in. So if we imagine that now, any one of those switches goes down. So say the phones in this example, we can still send information across from one to another. So if you've got servers and things like that, it's there. So the next part now is to increase our bandwidth going between our distribution. Now, just bear in mind, I've put it here at the aggregation layer. When you're looking at smart switches and things, you can absolutely do link aggregation at the edge and anywhere in your network design, as long as it understands link aggregation, which is a very standardized way actually of increasing bandwidth. So let's have a look at that now. So link aggregation, if we just use one of our copper ports, for example, we're going to have a 1 gigabit link, and what we've done here is we've just uplinked the second switch into that network. There's no redundancy there. Adding a second connection actually means that we are putting them into what's called a port channel. Now, what a port channel means is that it's the same logical link, so it's one link now, but it's using both of those ports, and it's now a 2 gigabit link connection between those devices. So we've actually got 2 gigabits. More importantly, if our wire was to break or a port was to blow, we would still have the redundancy that's left over from us because that other link is still working logically. We can add more cable connections. We can add up to 8 on some of these devices. And what that would be done is put into what is called a lag group, which is link aggregation group. So I've done a group here of 8 links that blocks that is an 8 gigabit connection between those devices. Okay.
It's a lot of ports on the switch to take up though, Craig, isn't it?
It is a lot of ports. Where I would use it, Alan, is not so much as 8 ports there.
Yeah.
That's just an example of what you can do as a maximum. I might use 2 or 3 ports and sacrifice it. Now, if you imagine that maybe this isn't a 10 gig switch, or maybe one of these is a 10 gig switch and the other one is maybe just a standard 1 gig ports that are available to it, but you've got, say, 16 cameras that are trying to run 4K video streams. So
Right.
like a surveillance solution, for example, maybe 1 gig connection, trying to pump that up to an NVR that's plugged into the top switch isn't going to work. It's not enough bandwidth. So maybe just add in an extra cable increases that bandwidth between each other, and that's enough to send all the traffic from our switches and our cameras to our NVR solution that's stored at the core. That's the reason why we do it. Likewise, if the other ports were all full up of data users, you imagine everybody is trying to download things these days and trying to do their work and pull images and things like that. Sometimes having an extra bit of throughput between that and the core is enough to keep your company running for another couple of years before you consider a refresh at some point.
Well, anything to sell more switches, Craig. That's what we do. We should start selling cables as well after this course, shouldn't we?
Absolutely. Okay, so again, we're looking at our switch now, and what I've done is I've gone to layer 2 features and then gone to my link aggregation. And what I'm trying to implement here is called LACP, Link Aggregation Control Protocol. Okay, so what I've said is on unit 1, and my ports, and then I've just turned the mode to on, or I might even put it into LACP mode or active mode, and then I've added a port channel. So what happens when I add a port channel? Let's have a look. Now you can see that I've used ports 25 and 26 as my link aggregation. I've put them into what is called a bundle group, and that's what I mean by that link aggregation group. It's called a bundle group in some cases. So port 25 and 26 is that link, and that goes to another switch. And on that switch, I've also created a link aggregation group now. So the port channel now is created, and what I can actually do with that port channel is I can treat it like a normal trunk. So if I want to do VLANs and things like that, I can absolutely send data down that logical cable, because really from the switch's perspective, this is one link now, and if I was to implement so many VLANs on that device, or have it as a VLAN trunk, it's going to operate no different to any other port. Okay.
Okay.
So that's back to our diagram again. Let's have a look at the last step that we're going to have a look at, or second to last step that we're going to have a look at. So what we're going to do now is, I mentioned stacking. Personally, I think stacking is a great way to implement things. There are other methods though, so I want to try and get you thinking about different types of methods that you can use. And one of those is called VRRP. So let's have a look at how VRRP might change our network. Okay.
Ooh.
Now what I've done there is I've broken our stack down, so they're not actually stacked now. They don't have the same IP addresses, but I'm going to introduce another cabling method, and that's our VRRP. So if you want to click that, Alan. So this is the area we're focusing, and then that's our VRRP connection. Now, this is slightly different. What this means is that we have two switches that are running all the time. However, all of the cables have to go to one switch, and all of the cables have to go to another switch. Okay, so it's not like there's partial cabling going along. What we're doing is we're having these independent links, and we can shape and manage our traffic based upon these virtual routing protocols, right? So let's have a quick think about how our VRRP can work in another level. So you can link aggregate between these two devices. One is active, one is on standby. So you always have them up and running. You don't actually have to physically turn them on or anything like that. It's always ready to go for that other link. We can still do all of our LACP. So we've got our link aggregation going to our aggregation switches, or a distribution layer, should we say. And then we have our independent access layers going across. So if you imagine there, I've got a little bit of combination. I might have got spanning tree on that access layer going on to give us those extra links. I've got link aggregation between the distribution and the core, and I've even got link aggregation working along that VRRP area, which is virtually having an IP. So what it does is the left one will have an IP address, the right one will have a different IP address, and then there'll be a third IP address. That's what all the devices on the network use, and they share the virtual IP address, and they understand that when the other one isn't working, they talk to each other. When the other one isn't working, it knows the backup has to come online.
So this is a fairly powerful network that Craig has built here for this. So this would be for like a university campus, or a large large and medium sized business, as it were. Just to mention that if you need any help out there building your networks, we do have the Wi-Fi Planner tool, which is available through the VIP Plus portal, or we're still doing site surveys, but we're trying to keep them virtual for the moment. So if you do need any help building your networks, Craig is always available, and he's always happy for me to offer out his services to customers, because it's what he lives for, isn't it, Craig?
Yeah, absolutely. And I have to say, switching more, obviously things are slightly different these days, but switching more to a virtual site service does actually speed things up as well in most cases. So it's definitely something that's worth considering. We can just sit down and have a little screen sharing time. If you do need help with building a network, we're always here to help you with that. Okay.
Yeah, we did do a webinar on the Wi-Fi Planner tool, and you can have a look at that webinar to see the kind of results that we can get you. Could be a good leg up if you're trying to talk into a new client or something like that, to give them some quite professional looking drawings and networks and stuff. But anyway, back to the networks, and now we're on to is this the last piece of the network, Craig?
This is going to be, I think it's second to last, Alan. Let's see what's next.
Okay.
Okay, yeah. So we're going to, yeah, I think it's second to last. So we're looking at the wireless side now. Now, some people very rarely actually think about what wireless, just how important our wireless broadcasting can be. I mean, I don't know about you, Alan, but when I'm in the office, pretty much everything I do is Wi-Fi these days. There's very few things that I need a cable for, because when you're running from, into your meeting rooms or you're going from place to place, I'm running around completely wireless all the time these days. I do have obviously a docking station, so when I sit at my desk, I put my laptop into my docking station, and that is obviously cabled and gives me a nice fast connection back to our core. But wireless is so important for everybody. Now, what happens obviously when the wireless fails, when you've got an access point that goes offline, for most people in most installations, that's it, game over. That people were going to have to struggle and carry on. However, if you go into an installation, if we go into a wireless redundancy mode when we're doing our install and think about how we plan our access points, we can start thinking about what happens when something fails. Now, what it does mean is, yes, it might be a few additional access points than you used to. So, for example, if you think you can get away with 3 access points for a whole floor, as an example, maybe you'll be looking at maybe a 4th or 4th, maybe even a 5th access point in addition to that. But what that means is if that middle one fails, let's have a look what happens. And you're unfortunate enough to be in that middle, the other 2 access points power up. So they increase their strength and broadcast. Okay? So what that means is that person in the middle has the access point available to them to carry on with wireless redundancy. So if you plan that way, what you're actually doing is you're installing more access points, you're lowering the broadcast power of them, which is pretty much what you'd have to do in schools, most schools anyway. You actually have to reduce the powers of classes, because classes in a school environment are always right next to each other. And if you want to have that kind of connectivity for the children, there's obviously a lot of devices that they have, then generally you'll have a lot of access points which can be which are generally in the area anyway. So making use of that wireless redundancy is a really good tool, because it means that you're not overlapping the broadcast, which means that there's more bandwidth available, less overlapping channels, less resistance to getting a connection, and then when it fails over, you've still got connectivity.
And the other thing they can do, Craig, is talk to us about our new Wi-Fi 6 access points, which have even more capacity.
Absolutely, yeah, absolutely.
I'm terrible with the shameless plugs today. I apologise. But I have seen the access points are coming up on the next slide anyway, so I'm just jumping the gun ever so slightly.
Sure, absolutely. So what I was talking about there is our Nuclias Connect portfolio. And our Nuclias Connect portfolio has actually been around for a little while now in terms of the actual access points, because it actually used to be based on some of our older software. What we've done is we've updated the software, rebranded it, thrown on new firmware onto these devices so they can run with this new management platform. So if you have purchased some DAP access points in the past, chances are with a little bit of firmware upgrading and a new software install, you'll be able to actually make use of some of these newer technologies and get that network up and running with some wireless redundancy already.
And I think we'll be able to talk about some new stuff coming to Nuclias Connect on the next webinar in 3 weeks' time, which is going to be about what's coming up in 2021. So I'm not going to ruin anything now, because obviously we want you to come back and listen to the next webinar. But it's very, very exciting stuff coming, especially in Nuclias Cloud and Connect areas moving forwards.
Sounds good.
You act like you didn't know about it.
So the Nuclias Connect Hub. What is the Nuclias Connect Hub? I mentioned the software. The software was updated on Nuclias Connect. What we've done is we've taken a little box and we've thrown that software into our little box that can be rack mounted, put away, forgotten about, and will control all of your access points from a single central localized platform that also connects into our cloud product if you want it to. So that's, I like to stress that if you want it to, because there are some people that are a little bit against the cloud sometimes, especially when it comes to security. You don't have to. You can if you want to, and what that means is you can also cloud manage your Nuclias Connect installs. So that is something that's going to come out very soon for our single sign-on. Should be out by the end of this year at least, I believe, maybe
Brilliant.
before. So we are looking at about 100 access points for the Nuclias Connect Hub. However, if you use the Nuclias Connect software itself, which is freely available, you can have up to 1,000 access points, and that's going to be dependent on the strength of the machine that you actually install it on. Likewise, you can actually install that into services like Amazon's Web Services and Microsoft Azure and pretty much run your own cloud for free.
What we love about this product, though, Craig, is no blue screen of death. No need to have the latest Intel i9 processor. This is just a standalone unit that will just sit there and allow you to manage your access points. So you get that added level of reliability from something that is just Robinson, isn't it? It just does what it says on the tin, and
Yeah.
it's priced accordingly. It's a very reasonably priced product that will cost a lot less than having a dedicated laptop to managing your access points. So give us a shout if you want any more information on the hub.
Yeah, absolutely. Okay, back to our diagram now. I think we're going to have a look at one more part, which is quite important. That's our gateway device. So let's have a look at what we can do for our gateway.
4G?
4G. Goes back to our 4G conversation, doesn't it? So we obviously do sell routers with SIM cards that are built in, and they can also have a WAN port as well. More importantly, we also do business grade routers. So if you are in that business grade environment, what you can do is you can put in a USB stick into that device and have a 4G WAN failover as well. So it's not just a device that you have to have that specifically does 4G. If you have one of our DSR series gateways, then you can certainly think about having a 4G failover device. So it goes without saying that if your WAN connection goes down, maybe you've got a leased line, maybe you're having ISP problems, maybe there's a DNS issue one day, you obviously want to have a backup connection to keep everybody up and running, because so much is built into the cloud these days. So much data is being asked for. That's why we want a 4G connection. And it doesn't have to be something that's contractual. You can have it as a pay-as-you-go service. Most SIM cards will work with standard 4G USB dongles, and then you can do it that way. So that kind of completes our redundant network. We've got redundancy right from our gateway. We got it at our core level. We have it across our edge. And we have our topologies that makes use of all of these cables and how they're actually connected together as well.
And this, if you do all of this, you'll make Craig smile, which is the most important part.
Well, I think the point that we're trying to get across, Alan, is you don't obviously have to install all of these kind of things to make a redundant network. Just a little bit of this, a little bit of that somewhere on your network will probably be enough to make sure that you've got some disaster recovery, and it buys you some time as well. And most importantly, what you can do is both at the same time. Sometimes what you can do, like I mentioned about link aggregation, is creating some redundant links and improving the amount of throughput through your network as well. So having those options there, plus the fact that when you start doing stacking and things like that, you're considerably helping yourself save time and management as well. Well, that management piece where you have to make changes onto the network, and it's all automatic for you. Any one change you do on one switch rolls to the other switches. It's as if it's one switch. It's really worth thinking about for, and especially if you're thinking about a new refresh for your network.
And that's the point of the whole webinar, isn't it? It may cost a tiny bit more to have 4 or 5 access points instead of 3 access points, but especially if you're a hotel or something like that, what is one bad review when one access point goes down and 10 rooms can't get access to the internet? How much is that worth to your business versus a couple of extra, £100 APs to put up. So
Yeah,
it's
even
not,
if you're in a small office environment, Alan, and
yeah,
one of your access points fails, you're potentially talking in a large office of 40 people, maybe that's about 6 or 7 people that can't get connected to do their jobs at
yeah,
that given time, and it stops them from going to meetings and things like that. There's this big, we see it such as black and white, but really there's this big knock-on effect. It's like dropping a stone into a pool and seeing where the ripples go. It
yeah.
can save a lot of time. So
Well, especially
and ultimately it can save you money as well.
Well, especially with more and more meetings going online, Craig. I mean, if you, we used to drive to meetings. We used to have meetings in restaurants and stuff like that, and that's just not happening now. It's just becoming meeting over lunch, delivered by Just Eat, while you while you chat on Zoom with someone. And imagine that without a failover solution, how much is your business going to lose missing all of those meetings, missing that interview, that chance for a contract, all of those kind of things. So just to mention as well, if you wanted to know any more detail on 4G, I mean, Craig, we've done a great job here. Craig's done a great job talking about it, but there is a bite-sized video which goes into this in a little bit more depth. It's only about 5 minutes or so, but it's well worth having a look at. And Craig shows the interface for how to set your 4G router into failover mode. So well worth a watch there. I'll link both that and the previous video that we did on network building blocks and business continuity in the sidebar, so that you can have a watch of those afterwards. So that's pretty much it from us for another webinar. Amazingly, Craig, we haven't got any questions today. I think we've set a lot of people's noodles are scratching, as it were. So we'll probably get some questions over email in the next few days when people take in what we've been talking about today, or have a chance to digest a lot, because we've really thrown a lot at people today. So maybe the questions will emerge a little bit more moving forward.
Yeah, absolutely. And certainly send them to UK-sales@dlink.com for any kind of questions that you have about network. If you're a little bit worried, perhaps, and not sure where to start, we can give you some pointers and help you out with some designs as well. So it's nice and easy for us to do. It's our bread and butter. So happy to help.
No problem. As I said, we will be back in 3 weeks. Time to go through what's big in 2021. I do apologise, Craig. We've had a late flurry of questions here, so I'm going to have to keep you on for another 5 minutes.
Oh, no problem. No problem.
So it shouldn't take too long. There's 3 questions. Hi, Alan and Craig. Where can I buy Wi-Fi 6 access points for my customers? Sorry, I couldn't read that. Then the screen wasn't quite big enough. I couldn't imagine the word customers. I had to double check. So yeah, no problem. You can buy your Wi-Fi 6 access points from your normal distributor of choice. Obviously, we don't favour one over the other. But if you do need any advice on what Wi-Fi 6 points are available, we have Cloud, we have Connect, we have Unify. We did a webinar on them 2 weeks ago, so you can go back and have a look at that, or you can give one of our helpful sales staff a call on 0208 955 9000, or that UKI-sales@dlink.com email address is always available. Craig, this one's for you. How does the Nuclias Connect platform compare to the likes of Armada?
Okay, so our platform is freely available. It doesn't cost any kind of fees in order to have access points on the licenses or anything like that.
Nice.
It's a single piece of software that you can install, and it'll install on things like Windows 7 quite easily, or Windows 10. Any kind of small device. It will, of course, install on Windows Server 2 as well, if you want to run it that way. And it can be stored in the cloud. Like I mentioned, Microsoft Azure and Amazon's Web Services. And what you can actually do is have it local or remote, and that's the key benefit. So if you wanted to host it as a centralized platform and maybe you do multiple installs, it can do that multi-level piece where we have multi-tenancy. So many sites connecting back to a central server, because how it would work is you could run, say, dynamic DNS. I think we've done a dynamic DNS before, Alan, as a webinar. As a bite size perhaps. And what that means is it reports back to that centralized server. You might have to open some ports up on your firewall for it to work, but ultimately you have full control over it. Now, whether it's going straight back to a hub or a Windows PC, it's exactly the same. It runs no different, and it also means that you can install it local as well. So if you do want that local piece and tie that into the cloud, you've got that option too. It runs back to will run back to our Nuclias Connect, our Nuclias Cloud Management piece, which is being implemented as we speak, actually. So fingers crossed that'll be up and running by the time this webinar goes live on YouTube.
Brilliant. Last question, Craig. Can I use 4G routers with SD-WAN to centrally manage them across a lot of sites? SD-WAN is something that's been talked about, upcoming from us over the past few webinars when we've looked at what's coming in the future. So we don't have SD-WAN in place as yet, but we may be talking about SD-WAN on the next webinar, I believe. But the question is, can I use 4G routers with SD-WAN to centrally manage them across a lot of sites?
At the moment, we don't have any 4G routers with SD-WAN enabled on them. Like you mentioned, Alan, we've got a SD-WAN gateway that's going to be coming out very shortly. And what that means is SD-WAN, for those who aren't really sure, means software-defined wide area networks. And what that means is having that centralized platform that allows you to direct different kinds of traffic to different places. So before, where we might have an MPLS line where we have a dedicated line that's lost some money, and all that services come across to an area, and that's going on and on and on into your cloud. What we can do is we can utilize ADSL, VDSL, that sort of technology. It's not going to be quite as fast. It's not going to be quite as what's the word I'm looking for? It's connectivity-wise, it's not going to be as optimal, but it does mean massive cost savings. Being able to manage how that traffic is being shaped, things like VoIP services, you could have as quality of service across the whole platform. So if you've got these big remote sites and you're linking them all together, that's where SD-WAN is going to be useful. Now, 4G wise, going back to 4G in the question, can you do that? Yes, you'll be able to do that onto our SD-WAN. I'm sure it will have a USB option available to it, but more on those details will follow later on.
Excellent. Thanks very much for your time, Craig. That's it for this week. We've overrun as usual, so apologies to everyone out there. I hope we kept you at least interested up until the end. As I said, join us again in 3 weeks, and we should have a great episode talking about what's coming in 2021. Hope to see you all again then. Thanks a lot. Bye now.
Thanks, everyone. Bye.